Hello, my name is Dr. Richmond Adebiaye. You can call me Dr. A or Richmond. So, because I have just 10 minutes. So, welcome to my teaching presentation, which is part of the interview process and represent a sample of my teaching demonstration. So, 10 minutes, and I will try to limit the topics as much as possible. The course description on this topic, machine learning, would help us to focus on the techniques and algorithm like nearest neighbor, regression, classification, perception, canal method, online learning, parametrics, active learning, clustering, and so many, including cross validation. At the end of this training that I'm presenting, I expect to achieve, I expect my student to be able to, one, demonstrate competence in the understanding of the basics of machine learning. Second, I expect my student to be able to demonstrate competence in understanding the tools needed for machine learning. And the third one would be to apply machine learning techniques to practical problems, to solving practical problems. And that is both the descriptions and the learning outcomes I expect to achieve at the end of this presentation. Now, let us ask ourselves, why do we have several statistical modeling techniques as the core in understanding this course? Yes, because machine learning involves that a computer to be trained using a given data set and then use this training to predict the properties of a given new data. We are training our computers or systems or applications by infusing in them with the intelligence to predict using a specific pattern. That is why machine learning is considered a subset of artificial intelligence. For example, we can train a computer by feeding it with, let's say, 2,000 images of dogs and 2,000 more images that are not of a dog, and tell each time to the computer whether a picture is a dog or not. Then, if we show the computer a new image, then from the training, the computer should be able to tell whether this new image is a dog or not. The process predict of training and prediction involves the use of specialized algorithms. We feed the training data to an algorithm, and the algorithm uses this training data to give predictions on new test data. And this is what we can conclude to be the process of, picturing what machine learning represent. Some of you who are programmers might be asking the question, but I can do this using traditional programming techniques. Yes, you can, but it will be more complex and time consuming. For example, I can ask you to write a program to scan an image, whether it is a cat or a dog. If you want to build this program using traditional programming techniques, your program is going to get overly complex. And as I said earlier, you will have to come up with lots of rules to look for specific curves, like curves, edges, colors in an image to tell if it's a cat or a dog. It could even be worse if I use the traditional programming in an example of asking you to extend the same program to support more animals, like I can say support uh, additional horses. So we now have we now have cats, dogs, and horses. This becomes even more complex as you will have to rewrite all the rules. So machine learning is a technique that helps to solve these kind of problems. And this is how it works. We build a model, an engine, and give it lots of metadata. E.g., we give it, for example, we give thousands or tens of thousands of pictures of cats and dogs. Our model will then find and learn patterns in the input data. So we can give it a new picture of a cat that hasn't been seen before and ask if it is a cat or a dog or a horse. So the more input data we give, the more accurate our model is going to be. This is just a basic example to let you understand what machine learning represents. Machine learning has other applications like that we have seen in the day-to-day running in the society. For example, we have seen autonomous vehicles, self-driving cars. We've seen electric vehicles. We've seen robotic language processing. We've seen vision processing and forecasting things like stock market trends, football draft predictions, weather games, and so on. Now, discuss about the three classifications of machine learning. We do call it types of machine learning. The one is the supervised learning, the second unsupervised, and the third is called reinforcement learning. Supervised learning is a machine learning task of learning a function that would map an input to an output. You understand? In supervised learning, we do have the data set on which we train our model is always labeled. So there's a clear and distinct mapping of input and output. You understand? Based on the example inputs, the model will be able to get trained in several instances. For example, we have a supervised learning. Example of supervised learning is spam filtering techniques. So it's part of machine learning process. The second one is the unsupervised learning. The unsupervised learning is where we don't get the users to supervise the model. Instead, it allows the model to figure on its own to get patterns and knowledge that was previously undetected. So it mainly deals with unlabeled data. The algorithm identifies the pattern, which the data sets is. It looks at the pattern and then learn them. You understand? So the algorithm will group the data into various clusters based on their identity. And using it, one can perform so many things like visualization on high dimensional data and so on. If you are very good in statistics, you would have used principal component analysis. This is an example of unsupervised machine learning task. Furthermore, statistical modeling techniques like k-means clustering is another example of unsupervised learning. The third one is works alongside the first two that I explained. However, you say you will get to understand this once we start, working on projects. Uh, uh, Reinforcement learning is emerging. It's not so popular, and the aim is to reach the goal in a dynamic environment. You can reach this goal based on several rewards that are provided to it by the system because it mostly heavily used in more advanced programmatic, stuff. For example, programmatic robots in autonomous vehicles, intelligent self-driving cars, and all that. it's used mostly. See, this let us know that in machine learning is evolving and it's going to continue to increase. If you are given a project in machine learning, what are the steps in a machine learning project? And that's what I'm going to talk about next. Let us assume you are asked to complete a project in machine learning. There are certain steps you need to follow. And I will want you to follow me and so that you can understand the steps. The first step is to import your data or our data, the one we are going to use. This often comes in the form of a CSV file or XLS file. You might have a database with lots of data or download different data sets from different databases. You can simply export that data set and store it in a CSV file. There's so many ways you can get your data set, so many databases you can get your data sets. The next step is to clean that data. This involves tasks such as removing duplicated data or redundancies. You all know redundancies and their bad effects on databases from your database class. For machine learning, we don't want a bad pattern that will produce wrong result. So if our data is like text-based, for example, like the name of countries, we have to convert them into numerical values. So it actually depends on the type of data we are working with in any project. The third step will be to split that data into two segmentations. First, the training segmentation and the testing set. Now that we have a clean data set, then we split it. And to make sure that our model produces the right result. For example, if you have 1,000 pictures of cats and dogs, we can reserve like perhaps like 70% for training and the other 30% for testing. The next step after that is to create a model. And this involves selecting an algorithm to analyze the data. This is where the core of the processes is because there are just so many different machine learning algorithms out there, such as decision trees, neural networks, and so on. Is there any questions so far? Okay. Each algorithm has its own advantages and disadvantages in terms of accuracy and performance. So the algorithm you choose depends on the kind of problems you are trying to solve and your data input. However, when we look at it from what is happening presently in machine learning, the good news is that we don't have to explicitly program an algorithm. There are libraries that provide these algorithms. This is a popular one I normally use for my own demonstration in class. It's called the scikit-learn, for example. So we build a model using an algorithm using scikit-learn. The next step would be to train our model. So we fit it into our training data. Our model will then look for the pattern in the data. Next is to ask it to make predictions. Let us think back to the example of cats and dogs that I gave earlier. We can ask our model, is this a cat or a dog? And our model will make a prediction. However, the prediction is not always accurate. In fact, when you start out, it's very likely that your prediction may be inaccurate. So the next step is to validate for improvement. So we need to evaluate the predictions and measure their accuracy. Then we need to get back to our model and either select a different algorithm that is going to produce more accurate results for the kind of problems we are trying to solve, or fine-tune the parameters of our model. So each algorithm has parameters that we can modify to optimize the accuracy. So those are the 7 steps for machine learning to start a machine learning project. Next, let us look at the libraries and tools for machine learning. Let's look at the libraries first. The first one is called the NumPy. The NumPy provides a multidimensional array. It's very popular. Another one is called Pandas. This is a data analysis library that provides the concept called data frame. What is a data frame? A data frame is a two-dimensional data structure similar to an Excel spreadsheet. So we have rows and columns. We can select data in a row or column or a range of rows and columns. Again, this is another popular, libraries. The third one is called Matplotlib. It is also a two-dimensional plotting library for creating graphs and plots. Then we have the last one, which is the scikit-learn. It's highly popular machine learning library that provides all these common algorithms like decision trees, neural network, and so on. There are other libraries you can find out there. When working with machine learning projects, we use an environment called Jupyter for writing our codes. I'm very sure most of you who have learned the introduction to Python will be very familiar with this. Technically, we can still use VS Code or other code editors, but these editors are not ideal for machine learning projects because we frequently need to inspect the data, and that is really hard in an environment like VS Code and also the terminal. For example, if you're working with a table of 10 or 20 columns or more, visualizing this data in a terminal window may be difficult and sometimes confusing or perhaps messy. So that's why we use Jupyter. It makes it really easy to inspect our data. To install Jupyter, you will use a platform called Anaconda at anaconda.com. I'm not going to go into details of this, as I believe you can download this on your own, including installation of the popular libraries like NumPy, Pandas, and so on. However, to start using Jupyter, we can open the terminal window and type Jupyter space and notebook. This will start the notebook server on your machine. You can see the default messages that come up when I did it here, and don't worry about them. It automatically open a browser window pointing to the local host port. As you can see, this is what we call Jupyter dashboard. So I'm very sure most of you who have done Python would, find this very easy. In the dashboard, we have few tabs. The first tab is the File tab. And by default, this points to your home directory. What you see differs between computers. I won't go deep into this, as you can learn this in your Python class or on your own. However, we need to download the data set that we need. There are several databases that you can get data sets from or download from. For example, Kaggle, Statista, and so on. Kaggle is very popular. Let us assume that we have a data set that we downloaded from Kaggle. Let's call it, call it sales of video games. Most data sets for sales are usually very good for training. So let us pull the data set from Kaggle. As I did here, as you can see, the data set includes the sales data for more than 16,000 video games on this page. You can see the description of various columns in this data set, like we have rank, name, platform, year, and so on. This represents our data source, which is a CSV file, and I will call it vgsales.csv. As you can see, there are over like 16,000 rows and 11 columns in this data set. Right below that, you can see the first few records of this data set. So here is our first record. The ranking of this game, as you can see, is 1. And it's also is the Wii Sport game for Wii as the platform. And it was released, if you look at year 2006. The next is to download the data set. Once downloaded into your computer, it gives you like a zip. It becomes, you download it as a zip file. We can then import the data center Jupyter notebook using different syntax or code. For example, we can use the code import pandas as PD. If you see, pandas used here mean that get the average of your data across a specified axis. So you can get the mean across a data frame's rows or columns or a panda series. So you see, that's the reason why we said import pandas as PD. So with this, we are importing pandas module and renaming it to PD. So we don't have to type pandas all the time in this code. You understand? So next is to type PD representing pandas. So we have the code pd.read.csv. Here, we are passing the name of our CVS. Uh, we have CSV, sorry, as pd.read_csv. And in parentheses, we have vgsales.csv. Now, because this CSV file is in the current folder right next to our Jupyter notebook, we can easily load it. And this is the good thing about Jupyter. Otherwise, we have to supply the full path. You understand? That is the file. So this returns a data frame object, which is like the Excel spreadsheet. For example, using the syntax df for data frame. So we have something like df equal pd.read_csv parentheses vgcell.csv. Then type dv to inspect it and run the program after that. Now, after running the program, you can see the data frame with the rows and columns. There are other methods we can similarly use, and if we look at it, some of the most useful methods and attributes we can look at. One of them is shape. We can type this in our code as df.shape and then run it. Here, after running it, you see the shape of this data set showing over how many records? Over 16,598 records and 11 columns. Looking at this shows two-dimensional arrays. We can also use another method called describe. And the same thing we will do, we type the code df.describe, then we'll run. The beauty of Jupyter is that you can see the output of each segment at the bottom of the input data segment, which makes it easier to visualize than VS Code or using terminal windows. As you can see in this method described, it returns basic information about each column in a data set. As you can see in the column, the column with the numeric values for each column. We have the count, which is the number of records in that column. You can see our rank column, and you can see that it has like about 16,598 records. Year column has like 16,327 records. So this shows that some of our records don't have the value for the year column. So in the real data science or machine learning project, we'll have to use some techniques to clean up our data set. So our option is to remove the records that don't have a value for the year column, or we can assign them a, a default value, but that really depends on the project. If you check the year, and you will see also that the mean is there, which represent the average year for all these video games in our data set. And the year is 2006, as you can see. And this might be important in the problem we are trying to solve. We also have standard deviation, which is a measure to quantify the amount of variation in our set of values. We also have another one called minimum, which represent the minimum value for the year column in 1980. So quite often we work with a new data set because of the described method to get some basic statistics about our data. There are other attributes also we can use, but I can't do that because of time. I can't treat them because of time. Let us now work on a real problem in a machine learning. I'm not going to go into so much details because of time, but I'll give you the basic on how to get started. Let us assume we have an online music store. When our users sign up, we ask for specific attributes like age and gender, and based on their profile, we recommend various music albums they are likely to buy. You see this a lot on Amazon. When you register on Amazon and start buying with Amazon, you realize that later Amazon will start recommending based on your previous purchases. So what it does is that it predicts several users' product recommendation. So in this project, we want to use machine learning to increase sales. So we want to build a model and fit this model with some sample data based on the existing users. Our model will learn the pattern in our data so we can ask it to make predictions when a new user signs up. To predict using the new user's profile, what kind of music the user is interested in. So our model can then predict and say, oh, rap, it's a hip hop music, it's a pop music, and so on. Based on what we can make suggestions, based on that, we can make suggestions to the user. So this is a problem we are going to solve. To start this program, this project, we have to go back to the 7 steps in machine learning project I explained earlier. And, those steps represent how we would complete the project. So because of time, I'm not going to be able to go deep into using uploading the data sets and then running it using different codes to do the prediction. It will take a lot of time. It takes at least nothing less than 30 more minutes. So that is end of this is where I would stop. So from what I've been able to present, I've been able to show how you can achieve competence in understanding basics of machine learning. You should be able to demonstrate competence in understanding the tools needed for machine learning, and then be able to apply learning techniques to solving practical problems. Thank you very much.